All right, so you've got this huge scientific or engineering problem in front of you. You know, the kind that can make or break your project. The tool you pick, that can make all the difference. But how do you choose? Well, today, we're putting three heavyweights of scientific computing into the ring. You've got the industry titan MatLab, its open source twin Octave, and the super versatile challenger Python.
So, here's what we've got on tap. First, we'll dive into the world of scientific computing. Then, we'll meet our main players, MatLab, Octave, and Python. After that, we'll put them head-to-head. And finally, we'll figure out how you can choose the right tool for the job. Let's get started. Okay, first things first. Before we start comparing these tools, let's just set the stage a little. Think of a digital workshop. This is where modern science and engineering really comes to life. It's the place where scientists build these incredible mathematical models that can predict the future, where engineers simulate designs that don't even exist yet, and where researchers find those aha moments hidden inside mountains of data.
So let's say that's you. You're trying to model some super complex system, or maybe simulate a brand new design, or you're just staring at that giant mountain of data. Where do you even start? Seriously, how do the innovators of today actually get this stuff done?
Well, they use computational power tools. It's really that simple. Let's stick with that workshop idea for a second. Imagine you have a few options. There's the polished, all-in-one professional workstation. Then there's the reliable, community-built toolkit that everyone contributes to. And finally, you have this super adaptable garage with a custom tool for pretty much any job you can dream up. See where I'm going with this? Each of our three contenders fits one of these roles perfectly.
All right, let's start with the big one. MatLab. This is the established giant in the room. I mean, we're talking about the most popular commercial software of its kind, with over 4 million users in science, engineering, economics, you name it. This is that polished, professional, all-in-one workshop we were just talking about.
And, you know, its history really tells you everything you need to know. Look at this. It started back in the 60s as basically an interactive calculator for students. Super humble beginnings. But then, fast forward to the 80s, and boom, it's a commercial powerhouse. They start introducing these toolboxes for specific jobs, and it just keeps evolving. From interactive scripts in 2016 to an AI copilot on the way. This long, steady growth is exactly why everyone sees it as such a mature and reliable platform today.
Okay, so MATLAB is amazing. But what if you want all that power without the, hefty price tag? That's exactly where our next contender steps in. Let's talk about GNU Octave. People often call it MATLAB's twin, and for good reason. It was designed from the ground up to be almost perfectly compatible, but it's completely free and open source. And its origin story is just so cool. It really defines what Octave is all about. This thing wasn't dreamt up in some corporate boardroom. Nope, it was created for a chemical engineering course way back in 1988. And get this, its name is a shout-out to a professor who is legendary for his quick and dirty calculations. So right from its DNA, Octave has always been about one thing, making the power of MATLAB accessible to literally everyone, for free.
And that brings us to our third and final contender, Python. Now, Python is a different beast altogether. It wasn't born to be a scientific tool, not at all. It's a general-purpose language that just sort of grew into the scientific computing powerhouse. This is our adaptable garage, right? The one where you can find or even build a specialized tool for any job you could possibly think of.
See, with Python, the real magic isn't just the language itself. The secret sauce is its absolutely massive, sprawling ecosystem of community-built libraries. Think of them like plugins or apps for your phone. They give Python superpowers to do pretty much anything you can imagine. And this is a huge philosophical difference, right? We're going from one big integrated tool to this huge decentralized universe of possibilities built by the community.
And these right here, these are the all-stars of Python's scientific toolkit. You've got NumPy, which is the absolute foundation for any kind of numerical work. Then there's SciPy, which brings in the heavy-duty advanced algorithms. Pandas is your go-to for just wrangling massive amounts of data. Matplotlib, that's how you make all your beautiful plots and visualizations. And SymPy handles all that tricky symbolic math. You put them all together, and you've got a scientific environment that can go toe-to-toe with anyone. All right, we've met the contenders. Now it's time for the main event. Let's put them side by side. We're going to look at their core philosophy, the way you actually write the code, the syntax, and how their whole world is put together to see what really sets them apart. And this table really makes it all crystal clear. Look, on one side, you've got MATLAB and Octave with their integrated approach.
It's like buying a complete workshop, everything included right out of the box. Then on the other side, you've got Python's modular system, where you basically build your own workshop piece by piece. And that fundamental difference really trickles down into everything else, what they're best at, and of course the big one, how much they cost.
Okay, here's a really key difference, and it goes way back to their roots. In MATLAB and Octave, pretty much everything is treated as a matrix. A single number, that's just a one-by-one matrix to them. A line of text, you guessed it, a matrix of characters. It makes total sense when you remember that MATLAB stands for Matrix Laboratory. It's baked right into its DNA.
You know, even tiny little details in the syntax can tell you a lot about their different histories. Take comments, the notes you leave in your code. MATLAB uses a %sign. Python uses a hashtag. And Octave, true to its flexible nature, kind of just says, use whichever one you want. It seems like a small thing, but it really shows how they have their own distinct dialects.
Now here's a cool little detail that actually sets Octave apart from both MATLAB and Python. It supports some of these shorthand operators like ++ and += that you'd normally see in older languages like C++. Now for a developer coming from that world, this feels right at home. And believe it or not, it can sometimes give you a tiny little performance boost.
Okay, so we've been through the history, the philosophy, all the nitty-gritty details. Now for the million-dollar question. How do you actually choose? Well, it really just comes down to matching the right tool to your specific needs and your situation.
Let's break it down into a simple 3-step guide. First, just think about your environment. Are you in a big engineering firm that probably already has MATLAB licenses for everyone? Or are you in a scrappy startup where Python is king? Second, and this is a big one, what's your budget? That can often make the choice between MATLAB and the free options for you. And third, what's the scope of your project? Is it pure mathematical modeling? MATLAB and Octave are built for that. But if you need to, say, wrap your model in a web app, Python is going to be your best friend.
So let's just boil it all down. Who is each tool really for? MATLAB? That's for the pro, the engineer in a big company who needs that polished, fully supported environment with all the specialized toolboxes. Octave is the twin, right? It's for students, researchers, hobbyists, anyone who needs that MATLAB compatibility, but without the cost. And Python? That's the challenger. It's for the data scientist, the developer, the person who needs ultimate versatility to not just analyze stuff, but to build and deploy real-world applications.
So in the end, there's no single winner. What we have are 3 incredibly powerful, but very different choices. And to really understand the power of one of those choices, we need to look just a little bit beyond the science lab. I mean, if you had any doubt about how versatile Python is, just look at this list. YouTube, Instagram, Spotify. The very same language that scientists are using for cutting-edge modeling is the backbone of the apps you use every single day. It's just an amazing reminder that the line between scientific computing and everyday tech is getting blurrier and blurrier.
So you see, in the end, there is no single best tool. It just doesn't exist. There are just different tools for different jobs and for different creators like you. We've gone through the features, the syntax, the philosophies, but at the end of the day, the language is just a tool in your hand. The only real question left is, what are you going to build with it?